Welcome back to part 4. Here we're looking at balancing and identifying reaction types. In this case, looks like we've got one reactant and a bunch of products, so something's breaking down. This looks like your typical decomposition reaction. Here we've got a compound plus another compound giving two new compounds. This looks like we've got double replacement reaction. We've got our strontium and our bromine over here. Now our strontium's with the carbonate, so we're just swapping partners here. Here we've got two reactants, one product, a pretty clear sign that we've got a synthesis or a combination reaction. Down here we've got, it looks like a compound and an element, maybe a single replacement. Oh, it's in two new compounds. What am I doing here? Well, if you notice, we got carbons and hydrogens with oxygen producing carbon dioxide and water. This looks like a clear-cut case of a combustion reaction. Hydrocarbons, which a carbohydrate is one, plus oxygen, it's always going to produce carbon dioxide and water in a combustion reaction. And then lastly, it looks like we've got an element plus a compound gives a different compound and a new element. This looks like a typical single replacement reaction. Looks like our metals have swapped places. Aluminum has kicked out copper. Now aluminum's hanging out with the oxygen. Copper's all by its lonesome over here. So let's take a couple minutes to balance these. Notice here we've got an NH4. It's a polyatomic. Might look good that we can keep the polyatomic together, but oh no, it doesn't work that way. So we're going to have to look at this element at a time. Notice we've got oxygens and hydrogens everywhere. Let's save those for last. So let's take a look. Over here we've got two nitrogens. We only have one right here, so to get two nitrogens, we're just going to put a 2 out in front. We've got one carbon, we've got one carbon, so those are good. Here we've got 8 hydrogens, we've got 6 there, and another 2 there. That's going to give us 8 hydrogens, so we're good. 3 oxygens and 3 oxygens, so we're good there. Alright, so this is balanced. Here we've got strontium, we've got one strontium here, one strontium there, so that's balanced. 2 bromines, just one bromine here. Ignore that little thing that when I did a screen print from this, the cursor was right in front of there, so it picked that up. So to get 2 bromines over here, we're just going to have to put a 2 out in front. Let me make that 2 look a little clearer. So let's put a 2 out in front of there. Now we've got NH4s and we've got NH4s, so we've got 2 ammoniums here. Now we've got 2 ammoniums there, so we're good. And we've got 1 carbonate and 1 carbonate, so this is balanced. Here we've got 2 hydrogens, we have 3 hydrogens, we have 2 nitrogens, we've got 1 nitrogen. There's going to be a fun little trick with this one. Not really a trick, but we're going to see something goofy happen here. 2 hydrogens, 3 hydrogens, the number should pop in our head is 6, so how do we get 6 hydrogens over here? We're going to put a 3. How do we get 6 hydrogens over here? We're going to put a 2. And we're balanced. This wasn't the one that has a trick on it. I jumped ahead there. So we're good and we're balanced right here. So then let's take a look at this next one here, a combustion reaction. We've got 3 carbons, so let's get us 3 carbons over here. 8 hydrogens, we've got, what times 2 will give me 8? Well, that's 4. So here we've got 6 oxygens plus 4 oxygens will give us 10 oxygens. 10 divided by 2 will give us 5 O2s over here, so we're balanced. And this one we've got aluminum, we got 2 over there, so let's take a look at our 2 over here. We've got 3 oxygens here, so how do I get 3 oxygens over here? Let's put a 3 out in front. And here we've got 3 coppers, and we've got 3 coppers there. So now we're all balanced with that. Tune in for the next part where we're going to write the word equations for these.